everyone and welcome back to the channel. I've got here on the workbench the Telefunken Operette 6 that I restored last summer. And I wanted to make this video because I have a bit of an update on the radio. There are a couple of things that are still wrong with it, which I encountered along the way and which needs to be fixed. So we'll talk about that in this video. There is a second reason why I wanted to make this video, and that's because I wanted to make a statement that you see often on YouTube people restoring things, radios, but other things as well. They make videos about it just like me, and then they end the series or the restoration and they say, look, the device or the item is completely restored and the project is finished. And we all know that this is a bit of an illusion because, as we know with these old types of devices, issues will pop up as soon as you will start using it. You'll notice things that you didn't notice during the restoration, or things break down along the way. So yeah, lots of these devices, they are a continuous work in progress, let's say. I've had the same thing with the pinball machines that I restored in the past. You finish a restoration and as soon as you start using it, other things break, you need to fix them again. There's always something wrong. So it's also a bit to push back against the romanticizing of the idea that such a restoration is basically a one-time event, and after the restoration the device itself is good for many years. That's definitely not the case. So what is now wrong with the Operette at this point? Well, there are a couple of issues, and the main one, I think, is the fact that there is something wrong with the on-off switch. So see, I have the radio playing on FM now, but let's put it on pickup input for the moment. The pickup input in this radio is the Bluetooth, but that's not what I wanted to talk about. This, you see that sometimes the on-off switch doesn't completely turn off the radio. Just let me see if I can see. Voila, there we have it. See? Yeah, now it's turning off if you really push it hard enough. So if you really push it hard, then it turns off. But if you just like push it on a normal strength, then see, it doesn't. See, you have to switch on and off again. So that's something that needs to be checked. That's also something that I really think is important, because you don't want a radio like this turning on when it's not in use, or thinking that you turned it off. Like, for example, you have the radio playing, you leave the room and you are in a hurry, you quickly turn it off, but it's actually not turned off. See, all the power is still on, the magic guy is still on. So yeah, that's something that I really want to have fixed. So maybe we should start by trying to find the issue there. Okay, so I found the problem here. So see that over there, that is the activator for the on-off switch. The small pin in there in the middle, that's the on-off switch. See, let me just activate it. So this is on and this is off. Yeah, this is in the stuck position, so now it's not really off, but this is off, right? So the bracket that you have over here, this piece is connected to the on-off switch, and that over there, that small tab, is the real switch. Now I can't get the switch out because it's bolted here into the chassis on the side, and there is no way of getting to those screws, so I can't get it out. Now I'm gonna show you the difference between it being on and turned off correctly or not really turned off. So this way it's on, this way it's off, and see, here we go. This way it's okay, that's also off. See, this is the way when it gets stuck in the on position. And if I, with my tweezers here, slightly tap the switch, I only need to touch it slightly. See, then the radio turns off. So I think this will be a matter of just applying some contact cleaner into the switch and hoping that it gets lubricated a bit better, because I think it's just a matter of the switch not getting enough force to always go completely to the off position. See, now it's again stuck. If I take my tweezers, I only have to touch it very slightly, so I think it's just a matter of getting the switch lubricated and cleaned. So let me just try that. See, it's still getting stuck in this weird position. See, it still gets sometimes stuck in this. See, now I have the impression that it always almost gets. See, okay, so I think I found the issue. Cleaning the switch didn't help, but if you look over there, I don't know, I have no idea if this is gonna show up on video. See that small tap over there? See, that's the one which the levers pulls this one back. So if you push the off switch, now I have the off switch pressed down. So if you push the off switch, then you pull back this lever. See? This is in the on position, and this is when you push the off switch. Now probably what I think is that over time the edge of this small slit wore out a bit, and as a result you cannot push it back far enough to activate the entire switch, because the lever itself also stops. It has a maximum throw as well, so you cannot push it down further to have actually that part over there. It needs to go further to the top of the screen here, and that's probably, I think, because yeah, over time the end of this hole or this slit has been worn out a bit. See, so now I have a wire sticking in there. I just put a bare wire in there just to cover up the hole or make the hole a bit smaller. If I then go and activate the switch, then so now I push the off switch. Yeah, then obviously it works perfectly. So I need to find something to make that slit over there a bit smaller. Okay, look, so I managed to get the wire twisted around it, but now the question is probably obviously how am I going to get this snapped off, this wire? Let me think about that, because see, I have now this wire here wrapped around it. See, now it's working a lot better. Still not perfect, because yeah, from time to time it still gets stuck. See, but then you can just push again and it works well, much better. But yeah, how I'm gonna get this wire snapped off, no idea. Okay, so I got the wire snapped off as far as I could, but that's definitely not far enough. See, still a whole piece there that I need to cut off, and there is no way I can get in there with my pliers. So I have here a couple of files, all for iron or steel, and let's see if we can get in there with one of these, see if we can basically cut the wire like that. Okay, let me try this without having to hold the camera. All right, I managed to cut it off with a file. That was a hell of a lot of work just to get a simple wire wound around that slit over there. Yeah, so see if now this is off. Sorry, this is on, and this is off. So yeah, the wire is just a bit loose, but it's not going anywhere and it's not hitting anything. So I guess that's fine. We see the switch is now closing correctly. If you press the off switch, even if you press it slowly, if you take the effort to press it all the way to the bottom, then it closes. See? Okay. That's that. Alright, up to the next issue. Okay, so the next problem that I'm having is an issue with the Bluetooth module. So I took it out of the cabinet here, put it here on top temporarily to just try to debug it. And I have my scope here hooked up to the output of the Bluetooth module. And I'm now via Bluetooth generating a 400 Hz tone. Wait, let me turn up the volume so then you can hear it. I don't know if you can hear it also on the video, but it's slightly distorted. It's not really a clean 400 Hz tone, and you can also see it on the scope. See over there that yeah, we do have a bit of distortion here in the signal. And the idea is now to figure out where this is coming from. So remember, in the past I also had issues of the Bluetooth itself, so the transmission of the Bluetooth signal itself causing interference on the module, and that's why I applied this metal tape here. And there was also another issue when we had some interference, and that could be was linked to the fact on how I was converting stereo to mono. I was just simply shorting these two pins here together, and yeah, so it seems like the distortion is back, or it's a different type of distortion now. So I'll have to start and debug now where this is coming from. This is the schematic over here. Oh, I can't really see it. Yeah, okay. So this is the schematic over here. This is the schematic of the PCB, the Bluetooth PCB. It's designed by Manuel Caldera from Electronics Old and New. So what it basically does here on it's this area in which we are interested. This is basically an amplifier. So here you have the input left and right channel from the Bluetooth module. Here you have the output towards the radio pickup input, and then if you have an amplifier on each channel. All right, I think I found something here. Instead of outputting a 400 Hz tone, see what I get when I output a 10 kilohertz tone. See, if I increase the volume, you clearly hear that this is very distorted. So I did a bit of searching online, and I found some interesting facts about the op amp which is used here, the LM358, and yeah, it's not really a good op amp to use for audio, just like it is just normally connected, let's say. And what you see here is crossover distortion, which is more noticeable on the higher frequencies than on the lower ones. That's why I didn't see that much distortion on the 400 Hz tone, but here on the 10 kilohertz, yeah, this is really noticeable. Now, there is a possible fix for this, and let me show you. I'm now putting here this resistor in series with something or in parallel with something, and look at that. Perfectly clean sine wave at 10 kilohertz. And see, now I will take out the resistor now. So what am I doing here? So I soldered here a couple of tabs, two test points to pin 1 and pin 4 of the op amp. And I basically connected this resistor between pin 1 and pin 4. Now what does this do? Basically pin 1 is here the output of the op amp, and pin 4 is the minus 9 volts supply. So basically what you do is you, if you put a resistor here between these two, you force the op amp to work in class A mode, which avoids, which let's say greatly reduces this crossover distortion. Now I found an interesting article about it. I will link it in the description of the video. Now pay attention, because the side effect of this is that the op amp will use more power as originally intended. But I don't think that will be a big issue here. Now what is important, however, according to this article, is that you make sure that the current which is going here through this resistor is not too high, so that you don't really overload one of the transistors inside the op amp. And that's why I'm now here, I put my amp meter, milliamp meter here in series with this resistor, and you see I have around 3.4 milliamps. Now they say that you should stay above 2.7 for this circuit to really have effect. But yeah, you should avoid going too high. So the value of the resistor shouldn't be too low. So you should stay close to 2.7 but still above it. So the 3.3 here is perfect. So I am now using here a resistor of 2.2 kilo ohms, and that gives me this current of 3.4, let's say, milliamps. Let's see what it happens when I switch it. So here I have a resistor of 1.5, so that means that if I switch this around, the current here should go up. Let's see if I can do this with one hand. Yeah, apparently I can. See, we have now 4.7 milliamps, and I tested the difference between the two resistors in audio quality. I cannot hear a difference. So I would suggest just staying with a value which is low enough to remove the distortion, but still, which is, indeed, but not too low so that your current doesn't go up. Okay, now maybe let me show you what the difference is on audio, because if you're, like I said, if you're listening to piano music, the difference is really huge. Alright, so I have some piano music running, and you can clearly hear the distortion. Let me now just put the resistor in series, or between pin 1 and pin 4. Yeah, I think that the result is clear. I mean, the effect is really noticeable. Anyway, I'm gonna tack the resistor here on the board, mount the board back into the cabinet, and leave it run for a while. See if the op amp doesn't get too hot. But yeah, now I can actually use the radio, because I do like to listen a lot to piano music, and this was really impossible with the previous setup. So let me just add this resistor here to the board. And that's how I decided to tack the resistor onto pin 1 and pin 4 of the op amp. chip of the LM358. And there we have the Bluetooth board installed back into the cabinet. Alright, so there we have it. The Bluetooth is now working much better. It's still not perfect. I do hear from time to time like slight tips of distortion. It's not the same type of distortion as it was before. It's just like if you have really simple piano music at the beginning of each tone, sometimes you do hear a little twitching still. But yeah, maybe it's also my ears, because I did get a classical music education, so maybe I hear these things too quickly. I don't know, but it's not perfect, but it's so much more usable than it was. See, here in this song you can also clearly hear the distortion that is still left in there. Yeah, that's that. What else did I do on the radio in the meantime? I replaced the power cable with a 3-prong cable, and I also grounded the chassis. What else? I checked all the tubes with my tube tester. They are all fine, except from the ECH81, which I already replaced by a new one. And that's it for now. I clearly say for now. I consider the project again finished, but who knows what happens in the future. Okay, so it's been a couple of weeks and I've been using the Operette lately quite frequently, just in daily usage to see if everything was going fine. Now, I have to say I am still not 100% satisfied with how the sound is over Bluetooth. Maybe I'm nitpicking here, but yeah, it's much better than it was, but it's still not great or not perfect. There is still slight hints of distortion from time to time, especially with piano music, because that's like very clear and clean tones that you get in this type of music, and there you can hear the slightest form of distortion that you get on your audio. Let's say it's 95% better than it was, but it's still not perfect. Okay, so just to see if I can improve it a bit, I went ahead and bought some op-amps which are intended to be used in audio, and these are NE5532. So I'm gonna take out the Bluetooth board again, remove the LM358 and the mod that I did to it with the resistor, and then put one of these in place, because really the LM358, whatever you do to it, it has never been intended to be used in audio. These ones, they are really designed as an audio op-amp. So yeah, let's see what we get with one of these in the circuit instead. Okay, so I replaced the op-amp, the LM358, with the NE5532. And honestly, I don't hear any or a lot of difference. I still have this very slight distortion in certain tones. But so yeah, I think it's not the op-amp. I think we are running here into the limitations of the Bluetooth module, or maybe the amplifier circuit. But anyway, I think I'm gonna leave it at this. I think it's acceptable. Most of the music that I'm playing sounds perfectly fine, sounds really great actually. It's only certain pieces of piano music that have very high notes that get a bit of distortion, but okay, I think I'm gonna leave it at this. Anyway, I'm glad I replaced the op amp because I'd rather have a dedicated audio op amp in there than an LM358 with the mod of the resistor that I was showing. So okay, I'm now gonna, yeah, let's say put it back in the living room, use it again for a couple of weeks or so, and see if it now runs fine. But that's it for the moment for the Telefunken Operette. If we have some other issues in the future with it, I'll show them again on the channel, obviously. But this one is gonna get some use now, so that's great. So if you're still watching, thanks. And if you haven't subscribed yet to my channel and you like what I'm doing, please subscribe, and then I'll see you next time. Take care. Bye bye.